So we just had a great conversation and I missed it. So let's do it again. So let's talk about parallel lines, okay? Okay. So what did you guys come up with? Tell me. Talk to me really quickly again. They have the same slope, okay? So lines that are parallel, they must have the same slope. So they must have the same slope. Okay. But they have to be non-vertical lines. Okay, if vertical lines are parallel, if they have different x-intercepts. Okay, so that's kind of a different, right? Because a vertical line, the slope we say is what? No, vertical line, undefined. So how do we talk about parallel lines that are vertical? That means that there have to be two vertical lines with different x-intercepts. Does that make sense? So think about like x equals 5 and then x equals -5, right? Those would be parallel, but they just have different x-intercepts. But we don't say that they have the same slope because their slope is undefined. So parallel lines have to have the same slope as long as it's a non-vertical, Okay, if we were going to draw like, as a result, so this would be something like, this would be two parallel lines here, okay? And if I called that line L and I called that line P, we would say that line L is parallel to line P. So that's the symbol that you would see in like a geometry class coming up next year. The two lines I put next to each other are parallel, meaning that they indeed are parallel, all right? So as a result of two lines having the same slope, you guys also told me that the two lines would never do what? Never intersect. So that's a result of having the same slope, two lines that would never intersect, okay? Okay, let's do a classic example for parallel lines. They're going to give you a point, and they'll give you something like, okay, write an equation of a line that is parallel to the line given and passes through the point 12, 5, okay? So we have y equals 2/3 x minus 1, and we have the point 12, 5. So I'm going to go ahead and graph both of these just to get an idea of what they look like. So we had y is equal to, what was it, 2/3 x? Is that right? Let me write it like this. 2/3 x, and then what was it, minus 1? Okay, so let's put that graph here on the plane. So here we go. This is our graph right here. And then what was the point that they want us to go through? Okay, 12, 5. So let's put that point on the graph as well. Oops, I missed it. All right, my bad. Let's put it on the graph. Okay, there we go. So here is the graph that I'm working with. Let's move it over a little bit. Let's make this as thick as it possibly can be so we can see it. Okay, so check this out. I have the point over there, and I have that line. So we want to create a new equation of a line that is parallel to my red one, but also goes through that blue dot. So when we create this new equation, we're going to check it to make sure that it is parallel and it goes through that dot. If it's a parallel line, what do we know about their slope? It's got to be the same, so we've been given that information, right? And what would the slope be in this case? It would be 2/3. You guys are absolutely correct. You guys are on the right track. So here's what we're going to start out by saying, okay? Well, we're going to start with point slope form because, look, we're given a point and we know the slope. We want it to be parallel. So let's start in point slope form, okay? And what is point slope form, you guys? Wow, you guys are awesome, man. Way to retain that information. Very good. So y minus y1 equals m times x minus x1. Good, no problem for us. So here we go. So I'm going to say y minus 5, right? Because this is my x1 and this is my y1. So y minus 5 is the slope. And since the slope is parallel, we want to have the same slope. So that's going to be 2/3, right? And then I'm going to have an x minus 12. Good, awesome. Okay. So y minus 5 equals 2/3 x minus 12. Okay, let's just change this into standard form then for ourselves. What are we going to do? Yeah, okay, we can distribute. So here we go. Let's do y minus 5 is equal to 2/3 of x minus, let's see here, 2 times 12 is 24 divided by 3. Yeah, -8. Very good. -8. Very good. Okay, now what do I want to do? The 5? That's a great idea. Let's move the 5 over, okay? So I'm going to have this. Y is equal to 2/3 x. What's -8 plus 5? -3. So we think that the equation should be y equals 2/3 x minus 3. So let's go back over to our little graph here and investigate. We have y is equal to 2/3 x minus 3. So if I take this information, I put it on the graph, there we go. Did we come up with a new line that is parallel to our red one and goes through our blue dot? Yes, it sure does, right? So we can even take this information and we can zoom out like super far, and we would still see that those lines are parallel, right? Even way out here, they become one line, right? Because we're so zoomed out. If they were not parallel, we would see a discrepancy in the two. But we can zoom way in. Look, I'm all the way down here like 1,000, right? And they look the same. But as I get closer, we can see these are definitely way parallel, and they go through that point, okay? Okay, here's the U-trig. Give you a point, -3, -1. Giving you an equation, y equals 2x plus 3. That's in slope-intercept form. So find the equation of a line in slope-intercept form that's parallel to 2x plus 3 and passes through the point -3, -1. Okay, what do you guys have for an answer here? Who wants to share? Somebody help me out. Okay, Will, what'd you get, dude?
I got y equals 2x minus 7.
You got 2x minus 7. Do we agree with that? No. Okay, what else did you guys come up with? 2x plus 5. Okay, well, you know what? Let's check them both. So keep this in mind for me here, okay? So what was the equation that we had? What was it? Y equals, what was it? 2x plus 3. Okay, so let's put that one on the graph. And then what was the point that we had? It was like -3, -1? -1, right? Is that right? -1, there we go. So, at the break, yeah. Okay, so let's hear it. Yeah, I see it. There it is, that point way down there. See a little tiny dot? Wow, let's make that a little thicker so we can see it. Ooh. There we go. Does that see it? Okay, so Will, what'd you come up with, dude?
Well, I know it's wrong because I did minus 3 plus 3.
Oh, okay. So it should be y equals 2x what? Plus 5. Okay, this is what you guys came up with. 2x plus 5, let's see. Yep, that looks pretty darn good to me, right? Even if I just change this to 2x plus 4, right? Notice that that's not going to work, even though it is still parallel, but it doesn't go through it as well, right? Okay, so far so good. Here we go. Let's see if you guys know this. So perpendicular lines. This is the symbol for perpendicular. You'll see this in geometry class, but it's kind of fun to introduce this thing a little bit early for you. So two lines are perpendicular if what? You guys know, yeah? Okay, what do you think here? Yeah. What? Yeah. Okay, if they intersect at 90 degrees, that's true. That's also a result of something. Okay, what do you think, Jay? Their slope is the negative reciprocal. That's also a result of something. No one ever gets this one. Anybody know what it is? Yes. They intersect at 90 degrees. That's what Alice said. Yep. I'm looking for something else. So yes, Will, what is it, buddy? No, if they have the same start. No, they could have two different start points. If you're talking about y-intercepts, they could have two different y-intercepts. You might know. Okay, here it is. Maybe we'll shed some light on this. Okay, if the product. What is that? What's the word product mean again? Multiplication. Right? If the product of their slopes is -1. That is the true definition for us for perpendicular lines. If the product of their slopes is -1. Okay, let me give you a quick little example of how and why, right? So let's say I give you the example y equals 2/3 x plus 11 and y equals -2/3 x minus 7. Okay, I have two different lines here. The slope of the first line here is 2/3. The slope of the second line is -2/3. When I multiply 2/3 by -2/3, I get -1. That's what guarantees that the two lines are perpendicular. The fact that the product of their slopes is -1. Now, as a result of two lines being perpendicular, sorry, it should be just -3/2. Yikes. -3/2. Excuse me. I wrote that backwards. There's that dyslexia again coming through. Okay, there we go. -3/2, -1. And yes, like you said before, right? They have opposite reciprocal slopes, right? But the way that we write it in the definition is that the product of their two slopes is -1. All right. But yes, opposite reciprocals, as you can see, right? So 2/3, the reciprocal of 2/3 is 3/2. The opposite of 2/3 is negative 2/3. So don't get the word opposite and reciprocal mixed up, okay? But for parallel, they have to be both. So let's do, say, if I give you the number 5, what's the opposite of number 5? Negative 5, right? What's the reciprocal of the number 5? 1/5, okay? If they have opposite and reciprocal slopes, that's perpendicular. So negative 1/5 when you put the both of them together. Yes, very good, okay? Many people confuse opposite and reciprocal. Okay, so here we go. So if I gave you y equals 10x plus 11, what would be the slope of a line perpendicular to 10x plus 11? Negative 1/10 x plus some other thing like plus 9, for example, right? Could be anything else besides that. Okay, opposite reciprocals. Okay, let's do a little investigation here. I've given you two different equations. The question will be, are these lines parallel, perpendicular, or neither of the two? Parallel, perpendicular, or neither of the two? How do you guys want to start? You guys lead this one. Okay, you're saying a lot of words, so what do we do? Well, you're absolutely on the right track, but tell me what to do first. Like pen to paper, what do I do first?
Can you divide by 4?
Oh, okay, so make them look the same, right? Make them look the same. So how do you want to make them look? Let's make them look like this. Why? Because I know the slope of this one. The slope of this one is what? It's 4/5. So I know that one right there. Oh, that's a bright highlighter. Sorry about that. Okay? So I like the idea of what you said before. Let's divide both sides by 4. Let's divide everything by 4. So I get y is equal to negative 5/4 x plus 12 over 4 is 3, right? Okay, what's the slope of this line? Okay, here we go. How do these slopes compare to each other? Are they opposite reciprocals? They are opposite reciprocals. They're definitely not the same, so like Jay was saying, so they're not parallel. They are opposite reciprocals, so therefore, if I multiply these together, if I multiply 4/5 with a negative 5/4, I get a product of negative 1. That guarantees that the two lines are what? Perpendicular. Very good.